Okay, so recording is ongoing now. So hello everyone, welcome to our today's session. And last time, as you remember, last time we talked about the operator overloading. So this is, let's say, the option we can use to simplify our syntax for different objects we create. But again, what I said before, we can achieve all these things using simple object-oriented programming, a usual object-oriented programming approach like methods. So mostly using methods and other class members. But yeah, so if you want, that would be an option that we use. The overloading of the operators. First of all, there still were some questions about the indexer for this private array you have in a home task in activity 4. And so for some of you it was not clear why don't we need to change the access modifier from private to protected or public, and how we need to achieve, or how we can achieve it without changing it. And so again, remember we have indexers, so maybe I will show a small similar example and then hope this would be clear for you. It's not clear, so let me open the solution. Let me add. Let me quickly create a dummy example. Let's see, I need to answer to my boss. So just my boss is writing. Okay, sorry. Okay, so let's reproduce the same situation. So basically, what happened there? We had two classes. So one class simply extends another class. So we have superclass and we have a subclass there. And basically here it's not the question about if the class is abstract or not. So this in this particular case the situation is the same for abstract and non-abstract classes. So in this case, if you want, I can declare the class as abstract, but there is no difference. So if you want, I can declare the class as abstract, but there won't be any difference. So let's say that would be my parent class. I will define it this way: class. Then what we have here, let's say we have the array here, private the integer array or string array, and that doesn't matter. This is just an example, so I can show it to you. So let's say we have the array. I can, if you want, I can initialize it later. So let's say we create the constructor here. Yeah, remember for abstract class you can also define the constructors. And so let's say here initialize the array. So let's say provide the size of the array, then I create the array with the size provided. So more people do not commands. Yeah, so here initialize it, and then yeah, so it is private. So and then again, how we can achieve it from the how we can access it from the subclass, or just from any other class. We can use indexer. So I use public. So I need to call the returning type, that will be string for getter. Yeah, and then that will be this. Then I need to use the brackets and the index to be provided here. So then I can define getter. Then for getter I will return. Then yeah, of course you can add the check if the index is greater than -1, or if it is less than the size of the array. But I hope you understand that we can do it. Yeah, so maybe at this point I will not add this check. But yeah, practice, we should do it. We should normally do it. And then yeah, so getter, it is, since we have public here, yeah, so this is also a really interesting thing. We have public here and we have no access modifier here. So it means that this getter will automatically be public. Yeah, and if I change the access modifier, so if I use other access modifier, for example, I use protected, then it means that I reduce the accessibility for this particular method. Yeah, so setter is actually also the method. Yeah, so it's callable code which can be executed, and that's why I can also protect it from using it from any from some places in the code. Yeah. So then, if the setter is protected, and okay, so just a small check. We have case 3 is on 1, case 5, connection is good. So okay, so just a small check. So yeah, and here we have setter, so it means that I can set the value, and then I can access the element of the array. And so you see, I use the methods. Yeah, I don't use I don't access this attribute directly. Okay. And here I set the value. And so just simple usual getter and setter. Yeah, one thing again, we have public here, protected here. Basically what will happen if we have protected here and protected here, it will show you the error because we simply have duplicate. Yeah, so it says accessibility modifier of accessor must be more restricted than the property of indexer. So it means that if we add access modifier here, then it should be more restrictive. So it means that I can use private, then that should be okay. Since private is more restricted than protected, because all the attributes which can be accessed as protected, they also can be accessed as private, but not all the attributes what are defined as protected can be accessed the same way as protected attributes are accessed. So private is more restricted than protected. It means that if you set any access modifier inside getter and setter, then it should be more restrictive. Or if you don't set it, then it means that it should be the same as protected. And it is obvious that it cannot be public, because like if we have the protected access to getters and setters, so that makes sense to have this access modifier public here, since again I cannot even access this method publicly, so obviously it's obvious that I cannot access it publicly from here. Yeah. So yeah, that's why I can set protected here, and I can set public here. And so it means that if I set private here, it means that I cannot use any access modifier, because private is the most restrictive access modifier. Okay. So, and basically, this is the method how we can access our array. And what does it mean? It means that basically I can access this method from, I can access getter from everywhere, since it's public, and I can access setter from the current class and also from the subclass. Yeah, why do we need it? Why do we need it? Simply because we have, again, this is the same question as why we need getters and setters. For getters, first we can change the access to these attributes. Like here we see that getter is public and setter is protected. Means that I can get the attributes from everywhere, but I can set the attributes only from the current class and from the subclass. Yeah, so this is the restriction here. And so if we simply have the attribute without getter and setter, then we cannot really then change the access modifier. Again, we can create getter and setter, but yeah, indexer means that you simply describe the object this way that you can indexate the elements inside this object. So it means that we can use that. So this is such pattern which can be used, and actually, yeah, why not? So then you have the situation when you have the subclass. Yes, so I can define the subclass. So let's sub I inherit from the superclass. Yeah, and then so what is this? Yeah, of course. Then remember, for the constructors, if we have parameterized constructor in the superclass, then it means that I need to call it from the subclass. Otherwise, there will be the error. Why? Because the constructor is parameterized. And remember one thing, that if we have the subclass and we create the object based on the subclass, then we must construct the object of the superclass as well. Yeah, so remember, we have this top-down pattern. Yeah, so it means that all the objects which are like in the hierarchy which are down, that means that they have all the same parameter. They have all the properties that every superclass has. Yeah, so it means that they all are inherited, and technically means that all the subclasses they are also the superclasses plus something more. Yeah, so it means that if we want to construct the object based on the subclass, we also need to construct the objects for all the superclasses it has, like the first superclass, then the superclass of the superclass, superclass of the superclass, and so on. And so all these superclasses must be the objects for all these superclasses must be created, and it means that the constructor for all these superclasses should be called. And if we have parameterized constructor, remember that in this case, if we define constructor with the parameters, then it means that all non-parameterized constructors are simply, they don't exist anymore. Yeah? So we override them with parameterized constructors, and if the constructor is parameterized, we need to pass, if the constructor is parameterized in the superclass, then it means that we need to call the method, not method, but constructor from the subclass to pass these parameters. So this means that I can do it here, and that would be public my sub. Then I Yeah, so here I can pass the parameter, then I can call the constructor of the base class, and so here I can still providing this it's provide implementation, but here is empty implementation, so that should be fine. Okay, so this is done, and then that was the question, how to access these attributes, and then the answer is simple. If I am inside current object, so let's say I have the method here, let it be public void my method, so I do something here, and then how can I access this attribute? So it's simple. I have public indexer method, which is available for me. I have public get, so it means that I can also access it from the subclass and also from outside the class. And then I have protected setter, so it means that I can only set the values from the subclass, from the object which belongs to the subclass and the current class, of course, and nothing else, nowhere else. Yeah, so it means that from here I can access the attribute. So let's say that I access first attribute, let's say first string here, this would be, and the second one I'll access from here, so that will be my second string. So, and I don't need to change the access modifier, I simply use indexer. So it means that indexers, they call actually these getters. Yeah, so what are defined as the indexers, and that means that I have no reason to access this attribute directly. Yeah, remember, if you have private access to any member of the class, it does not mean that you cannot access this attribute from the subclass or even from the other places. Yeah, that's because usually for private members you have getters and setters which are public or protected, and maybe also some related methods like here. Yeah, some related methods which do have the access to this method, to this attribute, and then these attributes, and then you can simply access them this way. Yeah, so that's the common practice that you will have such situation. So this is fine. And so let's say that I create this object from here, my object or something like this. Then I create the array. Let's say I have five elements, and so what I see from here. From here I can, of course, I can call public methods. Okay, this is fine. So this will set the attributes. And what can I do from here? So since I have public getter, it means that I can access the array attributes from here. So let's say it means that I can access the object. Here, remember, if I have this inside the object, yeah, so inside the current object, inside if I have instance methods, then I can access my current object using this keyword, and if it is outside, then it will simply be the variable which stores this object. Yeah? So if we have my object here, then if I go inside, like if it's to method, then my object is this, yeah, because it means that it's current object. Like same as for people, like if you look at me, then I will be as you, yeah. So if you address something to me, then this would be you say you, but from my side that will be I say I, me, yeah. So this is saying that for me this would be this, I, me, and for others this would be like you say you, or this guy, or name, my name, or something like this. Yeah. So this is just the way of communicating. Same as here. Yeah, this means it's me, it's my object, and then here my object would be the name of the variable which stores this object. Yeah, that's why we have this access modifier here. Then to access the attributes, from the object, we need to then do the same, but with the object, and then I can access these attributes. Yeah, let's say this way. So there, I can read them, but what can't I do here? I can't change the attributes from here. Basically I can't access setter because setter is protected. So it means that I can't access it. So if I try, you'll see that I have the error. So I cannot set the element from here because setter is set as protected. Yeah, so see it is inaccessible, and if this one is changed to public, yeah, so if we remove protected, we have public, then this is public as well, and then this would be correct. Yeah, so this is what the protected keyword does here. It does not allow me to change the value, to access this indexer, to change the value from outside the current class or the sub class. Okay. So and then we can run the program. It's loading. Yeah, so see that the elements are displayed as expected. Okay, so hope after this demo it's not clear for everyone why don't we need to change the attributes of the superclass to public or protected. That's simple because we don't need it. We have the indexer and then we can access. Instead of indexer, the similar approach would be if you create separate getter and setter methods. So if you create getters and setters, this will also be correct. But so as an alternative, we can use indexer. Yeah, so getter and setter would be that we have them here. That would be, so let's say that would be public array, public string array, ARR, and then we define getter and setter. Then we basically access this attribute using getters and setters. That would be fine as well. But that's just an alternative. Okay, so do you have any questions? Some of you are not clear about this. So is it clearer now? More clear for you? Or still some?
It looks more clear. Thank you. We will just try it out.
Yeah, that's good. That's good. Okay, then we can move on, and so let's go with the task about the vectors. Yeah, so I gave to you last time. So let's see how we can implement it. Yeah, so the idea would be simple, that we create the classes which deal with the class which deals with the vectors. So maybe I can use the same. Well, it's just like, let's say that I will create the new solution every time during each session. Then I will create new classes simply here, just to keep everything inside one class. However, you know, I can maybe let's maybe create a new class here. Yeah, I mean, there would be no difference for our testing purposes, but why not? We can create. So let's say we implement our own vector class. Okay, it is done. Okay, that would be vector class. Okay, so everything is fine, and now let's implement. So for vector we can, so as an alternative, as I said, so instead of using indexer, we can, so it depends, maybe let's use indexer, because for collections we mostly use indexers. Yeah? So for example, so we will work with some collections related, those who previously also touched array list a little bit, and list and linked list, so they all can be accessed, like, so have connections here. So let's say that's let's implement. Let me show it here. So we all this linked list. So I can write using a keyword, and then provide using namespace for linked list, where I can just simply access it directly. That would be collections. No, sorry, system collections generic. And then I can access linked list. So yeah, you see that the thing is that if we don't use using, if we don't use using directive, then we need to write such long statements and such long directives here. Yeah, so that's why we better define it on the top. Yeah, so this is why we use using directive, because otherwise we would need to then write such long lines of code. Yeah, and that's just to escape it. We use using directive on the top, and then instead I can find here. Yeah. So for linked list, you see that remember we can. I think we cannot. No, I guess for the setter that won't be possible yet to. To set the element, that won't be possible. Yeah, but if we want to show the element, for showing for showing that won't be possible. In the moment we have this for each, sorry. For each element in list, oh yeah, So, and basically this is based on the indexer approach, because otherwise, so I mean here for my bar we can also do it. So let's see, we have it here, and then I try to do a statement for each, and I think that should also be then possible here. So I use VR, say that will be on here in my object. Oh no, hold on. No, okay. Yeah, sorry. That's different. This is for enumerator. Yeah, we need to implement. Okay, then maybe let's keep this for now. There is a little bit, yeah, there's a little bit different approach used there, but still the access in the way of array can be implemented this. Okay, so maybe let's keep this for now. Let's go back to our vector class. Yeah, so maybe instead of indexer we can use as an alternative, that would be, yeah, let's then find, yeah, we can define getter, setter there, so that would be elements. So these would be elements, and here I can define getter and setter. Okay, so the similar would be that if we have protected setter, we can also undo it. Then it means that the elements cannot be set from any place. So maybe at this point, maybe let's do this one the same way, or we can keep it public. Yeah, that doesn't matter for us now. Oh yeah, so we have double elements which are okay. We have the array now. And okay, yeah. So if we define, then if we define this way, yeah, you see that if we define getter this way, it returns us the full array, but we don't need it. We need only to set or get one element. Yeah, so you see, then in this case, we can't actually escape using indexer. I mean, we can create a separate setter and method. So, for example, let's say we define this as private, and then yeah, actually, yeah. So the problem is, it will return you the array if you use get. So in this case, maybe that won't be the best approach. Yeah, so that's why let's stick using, yeah, because you see that if we use this getter, basically when we call get, what will it return us? It will return us the array, not the element. I cannot really do it this way, because like if I do get then return elements with this elements, then I say I provide elements, just any elements, then what will happen? So I use yeah, so first we see that it will not allow me to do it because I have the type which is double, but then if I change this, then this will still be incorrect, since the type is double and I want to access it as the array. This is the first point, and the second point is also obvious. This will simply go into endless loop. In this case, if I call elements getter from elements getter, this will go to endless loop. And so I have elements here. It means that I call getter from getter the same getter from the same getter, and I have no stop point. Means that this would be endless recursion, endless loop. So this is not good. So we see that in this case, the approach of using simple getter without indexer will not help us. As an alternative, we can create a custom getter. So that would be that we have private double elements. Then I can I can then create my separate setter. We call it void set elements. Then I need to provide position. So that would be double the element itself and position. Not index, yeah. So this is my class to code. And then I access elements. So it's just name. So then I would need to do it this way. So you see it is, I would say, quite a little bit longer. And so I need to separate sections. So probably then that will be public double get elements. Then here I need to provide index and then get corresponding element. So yeah, in this case you see that again it also, I would say this syntax, it's actually the same if we use indexer, yeah, so it basically does the same thing, but it is longer, yeah, so it is longer to write it, I would say, and also to access, actually to set element, we then need to call the whole method, like let's say that from here we create vector. So let's say if we create vector from here, then if I need to set elements, I don't need to write the full line here. So do it this way, and of course you see that that it is longer than just simply type something like this here, vector all equals stuff. Yeah? So you see that it is simple. Simply indexers are shorter than if we write the full methods. So this, I would say, this is the main advantage for the indexers. The disadvantage, I would say, would be that not same as for operator overloading. Not all the languages supported. So not all the languages have this option to use indexers, and that's why sometimes it may be the trouble if C# is called from somewhere else, or if we want to include C# somewhere, then this may be a little bit problematic. And method calling is, I would say, it is the same in maybe practically all the programming languages. So yeah, it's just I'd say multi-programming approach, method calling, comparing to the indexers or operator overloading, which is quite not say quite specific thing for C#, since it's also available in C++, but that's a pretty much specific thing for C# compared to other languages. Yeah, but so that's why maybe let's stick to, so just because it's longer, so maybe let's stick to indexer approach. But as an alternative, you can use this approach. So yeah, first of all, let's also define the constructor vector, then that's the size, and then we define the vector. We create the object for the vector, but it will be new. We have double, so it will be double, and it's the size. So, and yes, just for those of you who does not really understand why we need constructors and why can't we just simply skip constructors sometimes. So in case we use the object this way, you see that it is actually not possible to deal with this class. There is no actually sense for this class, for this object, without initializing the element vector. Yeah? So that's why we need parameterized constructor to be here. We can initialize, and then we can only create the object by providing the size, when we provide the size. Without providing size, it's not possible to create it. Okay, so it is then done, and then let's create indexers right now. So that would be, let's say that would be public. They're not protected, so then that would be public, and then I need to provide the type. The type will obviously be double. So then I use this. I can use the index here, and yeah, so let's use setter. So for setter, I think let's also use setter as public here. So get the yeah, let's define exception as well. Yeah, why not? So we can define our own exceptions. So that would be class index, well, let's say yeah, that would be exception index was 0 exception. So we can define exception. Remember that if we define exception, it means to extend one of the subclasses of the exception class or the exception class itself. So let's then do it. Wait, hold on. Here it is. So, and now we have our exception class. If you want, we can simply keep it as is. And then let's check. So if index is less than 0, I can call the exception. Call new index less than 0 exception. Else, if so then we can also check if index is greater or equals than the size of the array. Yeah, why we use equals, not just simply greater, because array start at 0. Remember, yeah. So that means that the last element would be size minus 1. Yeah. So this means that we can use this approach if index is greater or equals than the length, or as an alternative, we can. That would be the same since we deal with integer numbers. Then remember, then we can remove equals and then add minus 1 here, and that would be the same. So it's just simple math, and here we can define another exception. As an option, I can do this way. I can say incorrect index that goes in the exception class, and then I say that index less than 0, it extends incorrect exception class, incorrect index class, and then the same would be for index it's greater than size exception, and this will also be the subclass of incorrect index. Yeah, again, in such cases when you define the exceptions, it's not mandatory that you have any logic inside. Basically, sometimes that it is enough to define simple exception class without any logic, that just to manage your program using try-catch. So if you use try-catch, then you can simply you can manage all these exceptions here. Yeah, so you can handle them, you can manage the flow of your program, and then use try-catch properly. So yeah, then let's say I throw an exception here, so that would be index greater than 0, greater than 0, greater than the size of the array. So that would be this one. And else, if everything is correct, then I set. Again, you can, in theory, you can write any logic you want here. So it's not mandatory that you return exactly the value from this array. In theory, you can write any logic here, what you want to return. So this is just simply, it says, the program wants to access the element index, and then it points to the object. Yeah, then it basically, the program, when this is called, it calls the request to this method, so please give me the element index from this object, and then the request is taken. Then based on this request, you can proceed with any logic you want. So it's not mandatory that you always act with this elements object, elements member. You can write any logic you want here. And so and then if everything is correct, so we can access return the element. This will be returned. And then let's say I have setter. So the setter, setter would be the same here. Well, actually, I think, it's not possible to write the logic outside. That would be fun if we could write the logic outside and then apply it to both getters and setters. But okay, so that's this. I guess it's not possible. I can't imagine anyway, but okay. So that's fine. So then let's. Actually, there's one point. You see, we need to repeat the logic. We need to repeat 4 lines. So maybe I can, just to make it shorter, to not repeat the same code twice, what I can do, I can define private method, which then would validate index. Then I can provide index here, and then I can pass this logic here. Yeah, so the reason why I do it, which is simple, because I don't want to repeat the same logic twice. Yeah, I want to have it in getter and setter. So then what I can do, I can simply then call this validation from here, and that will be the same. Yeah. So that will be the same if I just simply use this logic here, and then instead of repeating this logic here, I simply call the same method from here. So it just simply, the reason is a shorter approach and more compact. Yeah, so I have validation here, I have validation here, so I don't need to repeat logic twice, the code twice. So yeah, and then I do validation. So validation is fine. Again, remember, if validation is not fine, then it will not execute. If here validation is not fine, it will not execute this line, since it will throw the exception. So it means that it will search for the nearest try catch where this exception is handled exception. Yeah, so it will search for the nearest catch statement where this exception is handled. That's why it means that if there is no, and as you can see, if there is no such catch here, it simply then means that it will search, it will go out of this getter, and here it will go out of the setter, and it will search for the nearest catch statement. Yeah. So that's why if the validation is done, then we can simply not use, can skip using any if else here, just proceed next is the logic. So okay, it's already done, so then I can set the corresponding elements to the array. Yeah, so then I set value. So now we can save, set and get the values. Do you have any questions about this? Okay, that's fine. Yeah, so we don't have these methods anymore here, so I can delete them and then we'll use it again. So yeah, this is done, and so now we are able to implement two operators. Yeah. So we can implement two operators, this class, and so let's do it. So that will be public static operator. So let's say we have sum of two vectors. So that means, let's start with sum. That means that it will return us a new vector. So it will as double, and the operator will be plus, and then we have vector 1, and then we have vector 2. So, and I can define maybe a new exception because vector size does not match. And then I can extend exception. Once again, maybe if you want, we can implement some logic there. And then yeah, I need to validate vector size. So again, I'll create a separate method because I'll need to use it multiple times. Same logic, so it means that will be private void validate vector sizes. So then we can provide the vectors here, and then I say if the length of comments, yeah, I need to get size. Okay, so we can then implement another method which will give us the size. Actually, that we want. Yes, I remember we can create the method length. So that will be public integer. That will be want, and here we can simply use a getter, which will then return the size of the array. And setter is not needed. I think so for such, let's say, dynamic attributes, the setter is not needed, since we simply get the length from the elements array. So yeah, then I can check the length. So if lengths are not the same, then I can raise the exception. So it will throw new, and so yeah, the vector size don't match. So then validation is done. Okay, so then I can call this method. Sorry, no, I can't. Okay, yeah, sorry, since this is a static method, then this should also be static. And it can be static since if we don't use access modifier this, then, if we don't use any elements from the current object, like we don't use this or any elements which belong to this, then we simply can use static instead of instance. Yeah? So that's actually that may be the answer to your. Some of you asked the question, why, when do we need to define the methods as static and when do we need to define them as instance? Then I would say we can always define static if we don't use any elements from this. So here you see that I don't use any elements from this object, then it means that I can define the method as static. This will be correct. Yes, so and it is private, so I can access them from inside the class. The results are the same. I can pass elements. And so, yeah, then I need to return the value. So it means that I create the new array. And so that will be double results. The size will be the same, right? And that would be, I can take the one from one of the vectors, it doesn't matter which one, since they are the same. Yeah, so that would be double. And then the size would be the one of the arrays. So then I can use for loop. For each, that would be more complicated, so that's why the easiest one would be that we use for I0, I less than length, yeah. So once, plus, and then I can sum two elements. So that would be result I equals simply vector 1I plus vector 2I. Yeah, actually here instead of double, instead of double, that would be vector. Yeah, sorry. Yeah, that will be correct. Then I can use vector, and then it will be vector as well here. So the only difference is, and I define this way. And basically, the vector would be the same as the work with the array. So yeah, then I access the attributes this way, and then I return the result. So the idea is pretty much straightforward. So then I can use the operator minus. It would be the same. So just simply then instead of plus we use minus here. So then it is the same. Let's do multiplication. For multiplication it will be also similar, but instead of vector we return the value. So then that would be the value, and then here I need to find double, and then I need to sum. So let's say I use one again. I can use one from one or another vector, since we already checked that the size for them is the length is the same. So it means that I need to simply multiplicate each element, and then basically what can I do? I can simply sum all these elements this way, and then I return result. So and this will be multiplication. What else? I guess for the operators that would be it. And so maybe, yeah. Oh, one more interesting thing what we can do. We can create factory method here. So what does it mean? It means that we can return vector based on the string what we can split at, or yeah, string. So let's say based on string. So the factory method. So I write it here. The example factory method. That would be public vector get vector from string. Yeah, so let's say we have string here. Let's call it string vector, for example. And then we have separator. So separator, let's say that would be the character. Okay. So, and then what I can do? Firstly I need to split string at separator, so that would be what I get a new array of string. That would be string elements, and then I can split string. So at this point we'll get the string which I can split at one specific separator. So that then means there is string vector, my fault, string vector of course. Then I can split at separator. Yeah. So and now I can what I think public static. So what I can do, I can create a new vector here. Then the size would be new vector, and then the size would be the size of the string element. And then I simply need to maintain each element, so I can use for each here. So I go through all the string elements. Yeah, of course, that would be bar string elements. And so define the variable in string elements, and then we can use try parse. Yeah, since remember why I use string elements, because I will write them from console. So in console I will simply write such string like one, something like this, and then I get the vector of 5 elements. The separator is space, so they will be split into the array, which has 5 elements, and the element has only the strings, but I need to convert string to integer, to double. And remember how we can do it, so we can use try parse, right? From double class we have try parse, and so here I can provide the element, so that would be my current element, and out would be the element I set into the vector. So that would be vector. Oh, hold on. Yeah, here we also need to use for. Yeah, sorry. We need to use for here as well, because I need to know index. So usually, remember, if you copy from one array into another, then you need to use for loop, since then you know the index. So you need to know what's done. Okay. Okay. So I have I here. Let's see, I check if I am the last in the ones. String elements. And then I increment I. So then that would be string elements I. And out I set parameter I from the vector. The thing is, it needs to be passed by reference. Okay, so then what can I do? I can with while, yes, but you still need to know the index. Okay, you can write while, so that would be this way, int I equals 0, while I is less than string length, and then you proceed, and then at the end you increment I. Yeah, so that would look this way. But this is a little bit longer. So if you, again, every time you need to use index I, and so if you go for each element of the array, like 1, 2, 3, 0, 1, 2, 3, 4, 5, 6, 7, then it's better to have it defined like this, so you can easily get it. Of course, every time for each loop, for do while loop, you can define it separately, like here, but for loop is the easiest way. Yeah, so that's why. And yes, here I cannot do it. So the question may be, why do I have the error here? Remember what happens. Let me quickly show you. So if I define an element like this, it will work. Yeah, it will work. But if I provide reference directly, to the element of the array, this will not work. So yeah, then I can get the element, and basically I can do the check if element is incorrect. So then I can raise parsing error. So I'm not sure what was the exception type. And so let me quickly check. Sharp parse exception. And yeah, it's straightforward. Parse is it is called parse exception. It's really called parse exception. Hold on, let me double check. Check the name of the exception. Not dynamic. Okay, but we can use word exception here. Yeah, see, I try to use more exception classes here. That's because I would say in practice exceptions are quite widely used in all the programming languages, in all the frameworks. Maybe with some exceptions, but from my experience, exceptions are used almost always. So that's why it's always better to use them. Why? Because again, as an advantage, here I would say you see the main advantage of exceptions. Because so what we have here, like let's say that I have method. So okay, in this case I call this method 3 times. That's all. Yeah, 3 times. That this is already, I would say, maybe not a lot, but that's significant amount of method calling. But let's say you have such methods called from 20 places or 40 or 100 places even. That would be possible. And then basically what happens here, you don't need to write if else. Yeah, so you can handle the exception, handle the incorrect or strange behavior of the program using if else, yeah, using branching. But then that would be that you have if, you have a long if, then you have else if, and these branches may be quite long. And what's the problem? The problem is that they do not catch. So using if else, that would be much longer. So let's say that you have call stack, and then you need to the exception handling without try catch. You can use only if else. So you can use only if branching. Then I would say that would be quite complicated, since you need to do this if else inside each statement. Then at some point you need to pass this information from one call stack to another. So remember, if we call one method from another, then we have call stack. Then we have another element in the stack. And then, so maybe again, just for you to imagine, call stack. And just quickly, yeah. So here is call stack. So every time we call one method from another, yeah, so one method, then we have this method calls another method, this method calls another method, and so on and so on. So if we want to use exception handling without the try catch, then we need to have if else inside each statement. Then if something goes wrong, we need to have if else again inside each of these call stacks. Then we need to pass this information from something went from one call stack to from one stack to another. Yeah, so like this method should know that something wrong happened inside this method. Then this method needs to know that something wrong happened inside this method, which knows that something wrong happened inside this method, and so on. So it means that you need to pass this information from one stack to another, and this actually requires, I would say, lots of if statements and also returning values you actually don't need them. So the solution would be to actually let, for example, this method know that something wrong happened here, and this affects the execution of this method. Then you can simply use try catch here. It will check all these method calls inside it. So this is the advantage. And same happens here. If something wrong is here, then it will return. It will search for the next, the nearest catch statement. Yeah. So this is the advantage, and I don't need to write any if else from outside this try catch. So from outside this method. Yeah, I have this one method only, which can then be used everywhere, and if something wrong happened, then this will go to the catch statement. So, and same I can do in other places, like here. So if the parsing is correct, then I can throw new forming exception. So then this will be also enough. Otherwise, if parsing is correct, then I can assign corresponding element to the vector. So, and here we can then proceed. Okay, so at this point, all the values are set, and at the end, if everything is good, I can return the vector there. Okay, so I can return then this vector. So the factory method is then complete. Yeah, so based on the string, which would be, let's say, takes string, say something like this. And then returns the vector objects. Okay. So, and I would say that would be practically it. So the last thing what we may need to do is that we create the vector. So let's say we can do it this way. I can ask user to please provide separator. For example, I will start with the separator, then that will be one character. And because the separator, this is what when we work with the texts, with the strings or CSV files, for example, then we usually don't know the separators which separate the columns, or which separate the columns, for example, or the elements. So we need to ask separately for them to be able to know them. So, and then I can find character that would be separate, and then I read it from console. Of course, that from console we read string, but character will be just simply one. So what we can do, we can get the first character provided, and so then I can ask for vector. So please, then I can ask user to provide us the vector. Please provide vector 1. and basically then I can directly use the factory method. So that would be the factory method. Oh, yeah. So, and oh yeah, then I need to provide separate, of course. Here it goes. Okay. So then let's say I have vector 2. And vector from string. And then the line, and the vector 2, and of course one sounds cute vector 8. Yeah, and here we have exceptions, so that's why I use try catch. And here this would be what we have format exception, right? And then I say I can write the error message. Vectors have correct format. Vector has format, and then I can maybe return. So I do not proceed further. If you want, you can ask user to repeat input. So that would be the alternative. Then let's say we multiply the vectors. No, sorry, let's sum the vectors. Oh yeah, by the way, let's display the vector. Yeah, so we have not overridden the toString method. So to display the vector as string, what we usually do, maybe not vector but all the objects as string, what we usually do, we override the methods toString. Override string to string. And then we return and this elements. Okay, yeah. There's one thing we will talk about it today, but and it's one moment. I will show you. So let me try. I think we can do it. Right, will this work? And these elements. Oh, no, sorry, not right one, but that would be. Okay, I guess in this point. I can make a new. Yeah, okay, so in this case I need to use the string builder. If I want to print out, get all the elements, I then need to use string builder. String builder, because I need to return the array as the string, so I guess maybe let's check if it's for the arrays. Can we? I guess if we, what was the default? Okay, let's check what was the default to string implementation for the array, because I don't remember, to be honest. And so to string, I want to display vector as vector, not as the reference. But let's then check. To be honest, I don't remember. That was the representation of the array. Okay. Okay. If not, then we will collect this. So. Let's then do the multiplication. And then we multiply both vectors. Vector 2. So then let's create a new one. So that will be vector sum. So then we will add one vector to another. And then vector subtraction b vector 1 minus vector 2. What else? Oh, yeah, actually maybe let's we have more options. We can multiply number by number as well. So then we can also overload the overloaded operator. So that means that we'll have public static that will be vector actually. Yeah, so you'll see that we also can overload this operation. That will be public static vector. I want to multiply vector by number. So remember that if we multiply vector by number, it simply means that we multiply each element by this number. So that would be vector, and then that would be operator. When I override operator multiplication, and then in this case, this would be interesting because I can multiply number by vector, and I can multiply vector by number. So from the programming point of view, these would be two different operations. From mathematical point of view, these would be two the same operations. But so from programming point of view, we need to implement them both. So that means that let's start with this one. And here, what I can do, I can say that I multiply by number. So that would be, let's say, C, number C. Then it means that I can do this. Okay, let's make them this way. So, yeah, so that means that I need to create a vector. And the vector, and then the size would be the same as the size of the vector. And let me try to do one thing here. Let me think if we can do it now or maybe not. Actually, there's one thing I want to introduce to you. I think we won't be able to do it now, maybe. Let me think. Okay, let's maybe try. I think we cannot get it. Okay, we can. Yeah, since we are inside the same class, we can actually also access the private private attributes from the object. Okay, so and what we can do here, we can yeah, that would be that would be vector. Then I access all the elements from the vector, and then I call this all. And so let me try. Then that would be x. So that would be double. And let me try the results. Yes, so I need to provide the index. Yeah, then okay, let's then I want to use them this way too. Let's start with the simple approach. Yeah, I want to introduce one of the expressions to you. We'll talk about them later today. So then, okay, I want to use them separately. And then we want some vector. And then I simply set I attribute equals corresponding attribute of vector times constant. And then I return back to return the result. So, and then again, mathematically, it doesn't matter which parameter goes first, which goes second. So, how can I implement the opposite one? So, what would be the easiest way how to write the multiplication operator, but vice versa for multiplication. Since what we do here, we multiply number by vector. Yeah, mathematically, it doesn't matter which goes first, which goes second. But here in program, we need to multiply both versions. And so, what do you think? That's the logical question. What would be the easiest way to implement it? That would be programming thinking. So what we can simply do, we can simply call the same method but change the sequence of the operator. So that would be that we define it this way. But what we simply do then, we simply then return vector times c. Yes, so I simply call this method from this method, and now they will be they both will implement what we need. Yes, so we have multiplication. What else is missed? Okay, we can implement also comparison of the methods. So we public boolean, public static boolean. We can compare to vectors. That will be compare. Vector 1, vector 2. The operator is right here. What have I missed? What have I missed here? Let's proceed with the code writing. Thank you, Ine. Misspelling. Okay, so operator. Yeah, thank you. Yeah, because basically you can always when you do the code formatting, remember you can always press Ctrl K plus D, and basically if you see something like you have the code here and the code like this, and the code is not formatted properly, you see that the brackets are not placed where they should be, so it means that something is really wrong. And so this is actually such hint that somewhere something is wrong. So if because formatting should fail only in cases when something is really wrong. And that's why you can take a look on it and determine if something is wrong. So okay, and then basically what can I do? I can go through all the elements of vectors. First I check if, in this case I don't need to validate since I just simply compare. So if the ones are different, then that would be false. So, and here I can again compare each element. So then if each element match each other, then the vectors are the same. So then I can say that the length, get the is based on length. Then I increment I, and then then I compare each element. So if simply means that if corresponding element one vector is not equal to the element of the second vector, then I return false. So then I go through all the elements, and then at the end, if everything is correct, I return true. So the same is for not equals to. So not equals means just the opposite one. So it means that I return not vector 1 equals vector 2. Okay. So what else? Need to implement equals and get hash code, so we can do it. Override bool equals. So we can so again I can check if not object is not if it is not vector, then I say that two objects are different, because if I compare object to something which is not vector to something which is not vector, then I can easily say that these are two different objects. So that they are not the same. If it's not, so if the object is not vector, then I simply say false. Else I can cast and compare. So else it means I can compare this to cast. Get hash code. Hash code is most unique for the hash functions, for the hash structures. So I can override it, but I will not override. Sorry. Right. And hash code. And then I simply can use base. Okay, so what else? What else we can implement? Do you have any suggestions for the vectors? Turn on the multiplication, addition, subtraction. What else? Yeah, by the way, how we can implement subtraction? There's actually, since now we implemented the multiplication by constant, we can also do it now. We can now do it differently. We can, since now we implemented the multiplication by number, so what we can do? We can return now. What we can do? We can say we add vector 1, and then we can multiply -1 by vector 2. Okay. So that would be the same, right? Since basically the subtraction means that we add the value multiplied by -1. Right? So this is what we can do. That would be the same. And that would be the smaller code, right? Okay. Yeah. So then let's test this out. So we implemented the multiplication. Okay. We can multiply by 3, let's say. So that would be, let's multiply by 3, for example. So maybe let's ask multiplicator then. And so, yeah, maybe let's ask user to enter. Right, multiplicator. Or multiplier. That would be multiplier. No, maybe let's just hard code this value. So that would be vector, let's say, multiply by 3. And that would be, let's say, multiply vector 1 by 3. Just to see the results. Okay, what else? That would be it. Let's also catch so what else we can catch? Yeah, array size, vector size do not match. What was the name of this class? Vector size do not match. Okay, vector. Yeah. So let's define. Yeah, so we need to define this class as public, because otherwise it won't be visible. It's not visible now. Let's try again. Yeah, my fault, because I defined all these classes inside another class. So these are inner classes. We'll maybe talk about inner classes later. So it means that I define one class inside another class. So in this case, it is possible to access them, but maybe let's not use inner classes for now. So then I say that still a moment. Yeah, maybe let's simply say that array size do not match. Okay. Or vector size, sorry. Vector size do not match. Okay. So let's try. Let's see what we have. yeah, I agree this may be a little bit tough, but I try to combine everything what we already know, so you can check it out. Yeah, sorry, by the way, you need to show the results, of course. You need to show the results, of course, yeah. So let me stop the program and then show the results, what we have here. So that one.
Maybe you can try CW double tab. I think it was the right combination.
Yes, CWW tab. CWW tab.
No, one C, one W, and 2 tabs.
No, it's sharp for me. CW tab. Oh no, sorry.
2 tabs.
C.
Like W, 2 tabs.
One moment. CW2 tabs. I get. Oh, fantastic. Thanks.
It just means we need to have a break.
1 moment. Let's maybe finish this.
Yeah.
Maybe. I actually want to finish before the break. So maybe let's quickly then write.
Done so hard.
No, I mean let's maybe finish and then after the break we will then proceed with the questions and also with the theory, because it's almost the end. So let's finish and then we'll proceed with the break. So okay, then let's say that actually some like in this case, yeah, regarding the shortcuts, I don't really. I like most of them, but not all of them, since because of this, like I need to then combine my fingers to manage them to type as it should be. So sometimes it's maybe a little bit complicated to do. So that's why sometimes I prefer to write fully here. So, and then I have the results. So let's say the multiplication. Then I write a sum. Here. Yeah, I can also use this inner syntax, like not simple plus, but not concatenating the strings, but including them, so that was possible. But I prefer maybe concatenating them. So we have multiplication, and now we have plus, and then the plus would be vector sum. Okay. Vector sum, and then here we have vector subtraction. And the last one, vector 1 multiplied by 3, and the result would be multiplication by 3, multiplied by 3. Okay, so now let's finally test it. So the separator would be space. Then vector 1 would be, let's say we have 6, we have 3, we have 5, and we have 7 maybe. Vector 2 would be 2, 8, let's say 3, and let's say that would be 6. Yeah, so unfortunately toString does not work as we expected. Maybe last thing to check before the break. I guess from the array class there was the way how they can be display to string moment C# array to string, I guess, or we need to write a code. Let me check. I forgot, but yeah, I didn't, but I forgot. Okay, one moment. Okay, we have the list for the array. For the array. Oh, yeah. Actually, let's maybe finally go to one of the expressions. One moment. Yes, I think we can finally do one of the expressions, and then after the break we'll talk about them. String. So then this would look like yes, and this would look like a little bit differently, but so like this string. Then we have the method, so that's the static method. Yes, the static method join. Then we can join them by space. And then what will we do? We can use then one of the expressions. And yeah, this will be the introduction to the next topic, but after the break. And here I can use select. So I can use select, and then this would be x, and this moment will be like this, if I'm not mistaken. Okay. So let's see. I'll explain the syntax after the break. Yeah, but before the break, let's check if everything works as expected. Then we can finally go to the break. So just want to finish this, and maybe we can have discussion about it after the break. So let's check. So space is here. So 2, 5, 3, 7, 4, 7, some random numbers here. Okay. Oh yeah, toString now works. So 2 minus. Okay. Okay, maybe I can keep it as is. You can check it maybe, but at least at first look it looks fine at first as expected. Okay, maybe let's finally have 10 minutes break now. Yeah, sorry, it was like long time without break, but so just that was.
Can we hope that you will push this code to the GitHub?
Yes, maybe I can push this code now to GitHub. You can take a look, because I agree that this may be fast for you. I agree, but don't worry, we can go through this code, and I will.
It's really nice examples. So we should check them carefully. So.
Yes. That's why I try to include almost everything as what we can include inside such code. And I will now. That's a good point. I will now push it in GitHub, so you don't want you to overwrite all this code, so you can easily access in GitHub. So no rush, no worries. Git commits. Maybe we'll have the second part. Not the second part of this task, but of today, but maybe not. Let's see. Let's commit the changes. Fantastic. And then we push the origin master. Okay. Yeah, so you should now be able to access this code, and I will go to the break now. So let's meet at 35 past 8, okay? So yeah. Okay, so let's continue. Yeah, so before before I ask you to ask questions, there is one thing what maybe I will show also the presentation, be the part of the presentation, and then we'll go back to the code. So here you see, so this is what I wanted to show you during this session. I want to show you the example, and here's finally the example is so here you can see we have lambda expressions. So this is one of the examples how lambda expressions would look like, but this would be the point. So what does it usually mean? Maybe let me show the presentation first, and then I will show you the examples. So that would be this one. Object pattern. We'll scroll down a little bit. We'll later on take a look on the object pattern, since I guess it's not important now. But so let's have a short look on the so-called lambda expressions. What does it mean? It means that we have a way how to make our code a little bit shorter, and how my boss says less understandable. Actually, my boss does not like all the new programming approaches. He's a little bit old-fashioned, and when using programming approaches, he comes from C++, and so it basically means that all the basics what comes from C programming, original C programming, he prefers such approaches only that come from C++ originally from C++. So he does not like these new syntax and similar stuff. But so nowadays I'm not really sure if it's becoming more and more popular. But there are some frameworks which use lambda expressions. So what does it mean? It means that basically for me when it was the first time when I've seen lambda expressions, it was in university, as I remember, some years ago. I don't remember how many years ago, but so then for me lambda expressions actually were unclear at all. But in fact, time by time, getting more experience, I understand that this approach is the approach of using lambda expressions is quite simple and quite understandable. But basically what this means that we have the arguments, and we simply pass the arguments further to the next methods. So for example, when we just cannot write it directly. Just let me quickly try. It's not possible. It's obviously not possible. But that's just the illustration. So it means that we get the arguments from somewhere, and then we pass them to function, and then we return them back to function. So one moment, let me maybe quickly try, I guess. That can be possible. That would be more. That would be quite maybe maybe not like this. Yeah, it's mostly used inside the methods, not just simply linear code. But yeah, so the key point is that we pass the parameters from one place to from one method, or basically from one place to another. And yeah, we can actually also use statement lambda. So this actually uses the statement, but statements. For example, yeah, maybe there is lazy object initialization. I'll talk about them maybe next. But first, let's take a look on what we have here. So here, what happens? I have join function. Join means that join itself means that it is the method which requires basically it actually requires lambda expressions by default. But moment, so let's check, I guess, if we okay, yeah, then in fact we can skip using this, but yeah, maybe in this case, in fact, we can do this like this, and that would be the same. Okay, maybe that was just a dumb example, but let's say that we want to implement something more interesting. For example, let's say that I want to. So let's say that we have the array. We have the array. Just not an array, and then I. Create the array and pass the elements. Yep, so yeah. Sorry, I rarely. Okay, maybe let's just.
Brackets on the left side.
You mean yeah. Thank you. Yeah, still unique. Yeah. just
late evening. It's okay.
Yeah, no, that's unique. I already missed the brackets. Okay, so that's yeah. So let's say now we have the array. And so let's say that I want to apply some kind of operation on each of these elements. So let's say maybe I want to add 1. Yeah, so let's say I want to add 1 to each of these elements. So how can I do this? And I want to create new array, for example. Or I can, so let's say I want to create new array which has all these elements, and we add 1 to each of them. So then yeah, as the first option would be, so let's say I'll write a comment. We want to add 1. Basically, I'll say we want to increment each element. So as the standard option, classical option for us would be that we use for loop. Let's say that would be I equals 0, I is less than size of the array, and so on. Yeah. So as usually, so increment I. So yeah, let's say that we start with the new array. So the array 1 plus 1. Yeah, let's call it this way. Array plus 1. And that would be new integer array. Much. Right here. Jesus, it's very long. Okay. Once. Okay. So and now I can simply say that this will look this way. So something is wrong. So it's wrong. Oh, yeah. Again. Yeah, what happens? Okay, so now it's better. So, okay, maybe I can just make it a little bit shorter, not using brackets as I like. Yeah, but basically, what's so it's, you see that we have 3 lines of code here. We need to process each element separately. We can make it shorter. We can make it shorter. Shorter approach would be this way. So I can simply write it in one line. So that will be, I go to array, I call the method select, and then I will select, I guess I can do this way. I need to make that one. Hold on. So why it doesn't work? I have double. Okay. That is the same. Oh, moment. Let's maybe. I guess maybe we need to then use link if I'm not mistaken. Let's try again. Okay, still does not work. Let's maybe try double then. What will happen then? Let's see. Double. Maybe for integer it is different. I haven't realized it before. Yeah, okay, yeah. Then for integer that was definitely okay. And why do I miss the cast? A moment. So it says that it will return me. Yeah, sorry, I can simply convert it to array. I can convert it to array because it returns the collection. The number of collection, and now I can convert it to array. So now everything's fine. Yeah, I actually was a little bit surprised that it does not exist for integer. To be honest, I'm not sure why. But okay, we can use double at this point. So yeah, you see that I can simply write it in one line using I guess that, yeah. Oh no, it is link. It is link. Okay. Well, hold on a moment. I guess we can use integer then. So sorry for your search check. Let's maybe just to be sure. No. Okay. Yeah. Okay. Yeah. I just forgot to use swing. I just forgot to use swing. Okay. Yeah. If you use swing, then you can. Yeah. So this is the library which helps you working with the namespace, which helps you working with the collection. Yeah, so it provides you additional operations on the collections, and mostly these operations use on the expressions. So basically, yeah, link is quite popular, I would say, and this is where lambda expressions are used. Yeah, you'll also see it another. Actually, I'm not sure if it is. If lambda expressions definitely are used in Java, and about other languages, I'm not really sure. Yeah, maybe just not lie to you. I definitely know that it's used in C# and also in Java. About other languages, I'm not really sure. But yeah, so then let's go back to the lambda expression. So you see, here we have this string. Yeah, the question may be where does x come from, and basically this is the argument. So the same as we have in mathematics. Here we have function f, and then we have the argument x. Yeah, so f from x. Yeah, like usual mathematical function f from x. So it means that we have the argument x to be passed to this function, and actually select. X means this will actually go through each element. Oh yeah, no, just to show you the result we have. So let me show you the result we have. Just you can see it yourself. Right, fine, and then yeah, we can join string. That would be the easiest, fastest way to display the array element, the elements of the array. Okay, so let's quickly take a look. So if I'm not mistaken, so let's check it out. And the program is running. Build succeeded finally. Yeah, so does it work? No. Okay, let's try again. Let's try this way. Because I guess this may trigger. Oh yeah, okay, we have postfix increments. I guess that was the reason. Let's check again. Yeah, so yeah, that was the reason. I guess if I do, yeah, I need to do, yeah, the same is here for postfix and prefix increment. Yeah, I just missed this point here. Yeah. So I guess if we do prefix increment, this will not show the correct result. Yeah, because remember, prefix increment means that we firstly increment, then pass to the operation, and if we do postfix increment, then means that we first will pass the value and then we increment it. But in this case, I don't see any sense why we need to do the postfix increment there. So if we do prefix increment here, yeah, so then it will be fine. Yeah, so now we see that all the values are incremented by 1, as we expected. Yeah, so this is the point, and basically what does this x mean? So yeah, we need to understand that for such lambda approaches, when we go through the collections, and it usually means that x, it is basically each element of the array. Yeah, so basically what does this code do? It goes through all the elements of the array here, and then it stores them as x. It's like for each, but it does it in a more compact way. Yeah, so basically for each is written in this line. Yeah, so it's quite short. It's the shortest way to iterate through the elements. Yeah, and then like each element is declared as x. Yeah, so this is each element, and then I use this. I'm not sure if it's called. How is it? It's called lambda expression. Yeah, I guess this symbol. Yeah, okay. Yeah, this is lambda expression. We use it, and then we pass it to the function. And here we have the function, which returns the result, which then is stored in the array, in the collection, which is at the end transported, but converted to the array. Yeah. So basically, again, the argument, the function, the iteration. Yeah. So you see, it's short. It's quite short, and yeah, as my boss says, this is it's quite strange and maybe not really understandable, but you can use it, and yeah, so maybe we can take a look on more examples. Yeah, basically mostly in C# you see it in link. Actually join, oh no, and select, okay, select, return it. Yes, we can also use filter if I'm not mistaken. Let's check. So is there yes, we have a filter. Let's select. Okay, what else we have? Let's maybe have a quick look on the methods. Appends. Append, okay, the append, it's not interesting. Let's we simply add the element. To average. Okay, this is just a simple method, not really interesting. Average. We have a function here. Okay, maybe. Yeah, maybe I want to have some kind of filter. Let's have a look, I guess. One moment. Quickly check. I don't see a filter method. Filter. Let's have a quick look. Where? Yeah, sorry. Same as in SQL. Yeah, linkers actually looks similar to SQL. We have select statement. Yeah, here we have where. Yeah, viewpoints. Yeah, we have where statement. Where and yeah. So here I need to say that x, and if I'm not mistaken, then moment we can say we have even numbers. Say x. Then let's write it this way: x modulo 2 equals 0. Okay, so this means something like that. Okay, and then yeah, then we need to convert it to array. Okay. And that's it. So let's take a look on this. Yeah, so if you have any questions, let me know. If anyone wants to ask something, and you can ask. Okay, so can we use accent here? Let's have a look. Yep. So you see that elements are filtered as expected. So again, so the same as select. Remember, select goes through all the elements. Each element is stored under x. Then x is passed to the function we proceed. Then it returns the value. Where here we also pass it to the function, but the function should yeah. So okay. So how you can check? You can go check the definition, and you see where it okay, it goes through the integer elements. That's fine. And here it expects function, which if I'm not, yeah, it means that it passes integer, and then it expects Boolean result. If I'm not mistaken, right? Yeah. It means this way. Yeah, so it expects integer value to be passed, and so here it is, integer value, it's passed, and then it gets the Boolean result as the return. So if result is true, so it actually waits for true result. If result is true, then filter is passed. If result is false, then the filter is not passed. Okay. So then we skip this. So and then obviously for odds we then can do the opposite, yeah, for us that would be just simply opposite one. Yeah, again, go through all the elements. Each element is stored as x. It is passed to the function. Function returns true or false. If true, where is passed? If false, where is not passed, and the element is filtered out. And then we get on. So let's quickly take a look how it looks like. Yeah, so you see that everything is fine here. Okay, so far, do you have any questions? I agree, this is a little bit maybe not classical way of code writing, but it is acceptable in C#, and you can use it. And it is shorter. Yeah, this is the key advantage. It is shorter, and I would say, at least from my experience, it is mostly used with the collections. So as the example, you can also actually define the function using this. So for example, let's try. So for example, yes, that should be action. Yeah, I can actually define the action. That would be write line action. Then I say I pass the parameter string to it. Say x, and then I pass it to the console. Write line. Okay, let me try to use this shortcut. So that would be CW double tap. Okay, I was almost successful here. Okay, let me write directly. Okay, and if I pass x here, will it work? Looks like UI. Okay, yeah, we don't do. Okay, then I think let's try them this way. Okay, right one, and can I pass any element to right one? Yeah, this is called delegate. One more introduction to you, because I cannot. No, I don't have x. So pass text, will it work? No, because it expects. Okay, it expects the arguments. Okay, and then like this. It's not take. Yeah, fortunately, delegates. I guess for delegates we cannot pass the arguments in a moment. So. Yeah, actually, the thing is, you can write the shortcuts also for the functions. For the functions, oh, hold on. Oh, okay, yeah, but then I guess the simple way would be if I then do it this way, and then I call it not action, but it's possible then to write it as an action. Okay, yeah, so you can declare it as delegate then. Right. Yeah, I need to then define it as another method name then. So that will be, let's say, I can define its private static delegate. Yeah, so then, yeah, to be able to delegate with the parameters, I can define separate delegate here. This is what I do here. Public, private, oh, no, sorry, separately here. Okay. So, now everything's fine. No, it's not fine. So what's the issue? Okay, yeah, static. I don't need static. So delegates. Yeah. Okay. So now it's fine. So yeah, this is one more thing I wanted to show you also today, that we can create the delegates, which simply means that we. So remember, we can write the delegates for the alias. We can create the aliases for the namespaces. Something similar is with the delegate functions. So it simply means that we can actually create the shortcut for our functions we want. So for example, here you see we have the function delegate, means that this will be the function which accepts one parameter. And then I can simply say that this would be current function. Then I can, instead of calling console write line, then passing the attribute, I can use the delegate. Yeah. Actually, this is, I would say, sometimes it's a little bit confusing, and maybe I suggest not to use delegates too much, because otherwise this may be confusing for those who read your code. We'll mention that if all the generic code will be replaced with your delegates, then of course that would be quite complicated to read such code. Yeah. But just for your information, you may see something like this. Yeah, so we define the delegate, we define the name of the delegate, then the type. Yeah, this would actually be the type for the delegate. Then we define the returning type, we define the parameter what will be used there, and then we define, actually we pass the method, instance of the method, to the delegate, and then we can call this method. Yeah. So, do you have any questions about this? So, okay, what else interesting we can do for the lambda expressions? For the lambda expressions, we can check some examples maybe. We can define our functions here, so there is such approach defining the functions, basically defining the functions as the variables. So that would be something like this. So I have this function, this is actually also delegate, and yeah, then I need to provide the parameters of this function. So let's say that I I need to have import. I need to have so that this would be the passing type. Yeah, the type of the parameter. Yes, I can also define 3 elements here if I'm not mistaken. Yeah, so yes, that would be. So here I need to provide the element type, and then let's say I define concatenation function.